Oh, this key was.
Even that, I saw the student, geometry, when they finished all chapters. Yesterday, some student, yesterday, the day before, yesterday. Oh, that is Algebra 1. They are doing this one. Of course, the pre-AP class. They're what you doing? Ooh, they do this.
Oh, yes.
Textbook doesn't have it, but right after all chapter done. So they are doing this. Irrational graph. I saw that. PhD students, yesterday. Even the geometry, after geometry, all 12 chapter done, right? They do the variety. Variety thing. Of course,
they do a lot of concepts, different concepts.
Especially this year is one totally different from last year. I don't know. Each single grade also they do different, harder than the previous year. I pay attention.
Things are getting advanced, so the curriculum is getting advanced.
Need to catch up the other country, catch up with the other country.
Hopefully.
Especially, this year, this is the first year. One of the father brought the school homework, third grade. Father used to be the Kumon student. So the second generation, that's what we know very well, right? Ms Fujiwara, help my daughter. What happened? So they do the equivalent fraction. Third grade.
Third grade? Which school?
KTISD. Reduction, reducing, and
in the
opposite.
third grade?
Third grade.
But they don't know long division by then.
No, that's the simple.
Simple one, the fractions.
Table.
Fraction.
If the table, that's why this year, the KTISD, multiplication, when they run the multiplication, they do the backward. Same thing. 4 times 6 equals 24. 24 divided by 4. They do that. Then reduction also, 6/9. Then opposite, 2/3 show the equivalent fraction. They change the denominator. Some of them done 6/9. The next one is 12. Denominator is 12. Need to find the numerator. On 24. Need to find the numerator. I was saying, wow.
That's why we should always say we need to be ahead 2-3 years.
2 years, at least 2 years.
Reading probably 2 years or 4.
Reading is not changing so much, actually. Reading is not changing so much. Math is one.
But comprehension in our Kumon curriculum, the higher they go, the stronger it becomes. Leave the
of course,
aside, right?
Of course,
If they're in D1, D2, if they're doing second grade comprehension, it comes out very fluent.
Even third grade is okay.
B2 and second grade doesn't really work out too much because they are not made.
B2 is okay,
B2 is good.
Anyway.
After this is B2,
and the second grade.
but I feel after C2 they start comprehending a little bit more.
Anyway, even the second grade, long paragraph. Long paragraph. So that's why when they look at the long paragraph, they shock. Brain gets shocked.
Yes. And one thing somebody was mentioning, somebody was mentioning at one of the meetings that we need to look because most of the kids read the questions and then go to the paragraph.
Right.
And if they don't read first and do it, they don't learn it the right way. So comprehension skill is not developing at all. They're just trying to get all the answers from the paragraph. Which in Kumon setting, it's not easy for figuring out how he's doing it, right? Can we do it with 60 kids sitting in the class? Not really.
Some students, right, they can apply very well.
They can apply
whatever they know, right? But some students cannot apply. If the same style question is we provide them, they can do it. So that's the start test time is before that. I just make copy, just practice if the parents request. Not so many.
Or you make start.
Because homework doesn't do the class. Okay. So bring them.
Where do we print the start test copies? Online?
No, I bought a book actually.
Huh?
I bought a book.
Oh, you bought a book.
$24 something each book. Very expensive
really?
Now.
For each grade?
Each grade, each subject, math and reading.
Where do you buy online?
Anyway, I went to the teacher supply. Teacher supply, the
Oh, okay.
same street,
Oh.
Tali, and I-10 feeder corner. They have teacher supply.
I-10 and?
Feeder, I-10, Tali, T-U-L-L-Y, Tali Stadium there.
Oh, the feeder on the south, let's see, you've got the eastbound, the westbound or the eastbound?
Yeah, so go to the eastbound. Yeah.
There are more stores.
But it's very close, right? So if I need it, I stop by over there.
Is it by that food store, the health food store, the teachers?
Actually,
Used to.
Yeah.
They're gone.
Oh, okay.
That's
but
health
it's
store.
in
Yeah.
that-
Organic, right? Kind of that.
Yeah. But that
Good
store's
stuff.
gone. Okay, but it's in that area.
Hibachi restaurant, yeah. Yao Ming owned that. Yeah.
Especially the
Yao
ESL.
Ming's family owned.
Oh.
But he's sponsor. Money comes from him.
Especially the ESL and the kids that we feel a little bit. Start practice is not bad.
Listen, they make not so much, yeah, because right, if the same type of the question that provided, the brain get familiar with how
So
to manage.
you bought those STAR tests and you copy for your
Yeah,
students?
only the first student. We don't sell anything, yeah, I don't sell. Just give a lot of practice, right? They cannot do everything, yeah.
That's good.
Just get familiar with the pattern.
Even Ms. Fujiwara, I'm getting calls that they want to do geometry practice in summer. So how do we answer that call? Can we do it?
We
not
don't
do
have
it?
a geometry. That's why I go to the geometry student in middle of the year, they quit. Oh, it's okay.
What is it? Geometry?
Middle of the school year, they quit.
Middle of his.
Middle of school year,
Uh-huh.
when the student taking geometry, they quit.
Yeah, because there's nothing. Do we have certain sections? I think I wrote it
No,
somewhere.
only the 171 through 200 is that is run, right? Pythagorean theorem. That section can be helpful, but only that.
Only that. K1 through 10, I think you mentioned too, right? K1 through 10? No.
K1 to 10 is
No.
the graphing, just
Geometric
that.
sequence. No.
No, it doesn't help.
Yeah, that doesn't help.
None of them help.
So all we
Only
have
the
is
M1 to 10.
M1 to 10.
That is right. When they learn the right Pythagorean theorem, after that they do the sine, cosine, tangent. That is only the one. 1 to 10. M, not
M1 to 10.
Don't change the number.
No,
M.
no, it's not here. It's not here. Yeah.
That one, yeah. M1 to 5, actually, that's enough. They don't need to do sine squared plus cosine squared equal 1. No, they don't need it.
So we cannot really. What about the graphs in H? The what about the graphing? The graphing helps still or no?
They have a geometry. Geometry, they do this because the parallel and the perpendicular is a word of the geometry, right? Belong to geometry. So they do the graphing that area again in geometry.
Right.
Give the equation, then passing
then
through this point, right?
Right.
They find the parallel.
Right.
Parallel
So
graph
that
which
would help
passing
a little
through.
bit, maybe.
But that time, right? They do the right point slope home instead of y equal mx plus b. No, not
they
the
don't.
point slope home. They use that.
That's it.
That is M.
What are you
M
saying, point slope?
slope home.
What's the last word you said?
Point slope.
Slope.
Form.
SLOPE.
FORM.
Point slope.
That means, right? This is y minus y1 equal m slope x minus x1. This is 1. So point is 1. For instance, right? 2 or 3 is given. This is x1, y1. Then some graph is y
Where do we do
equal
that? I haven't done M.
That's
This is
not
M.
in Kumon work.
M.
It's
Oh,
M.
not until.
M, I think the 151. I think so.
And
Probably.
the worksheet.
That's why the M,
M151.
that they need to do fast. M141, M. After L, M141 through 200 need to do fast. So that's unhelpful. Yeah. And the midpoint theorem, everything. Midpoint theorem also, they use it in geometry. Yeah. First chapter, actually, chapter 1, they do the midpoint theorem.
Where are the M worksheets? Anna?
141, 151, that
You have
area.
one. You have X. You have
M?
M141, 151, that is very
151.
helpful.
Let me see.
M?
Yeah.
You know, I hate to say, okay, whatever you
And the
want to come and practice.
perpendicular, is 1. something like that. This one, right? This is a graph. Parallel to this line, this line, and passing through this point, which means that how to apply this one is right. This is the slope, right?
Right.
Then y minus y1, this one, equal to slope is negative 2. X minus this one, 2. Oh, coincidence, yeah, this and that. So y equal, right, negative 2x plus 4, right? This one over here, so plus 3. So that's a negative 2x plus 7. That is a final answer. Parallel to this and passing through this point. This is it. Then also the perpendicular to this is a question also. Perpendicular to this. The perpendicular means, right, all the slope is m. New slope is m prime. Normally we do this. This product equal to negative 1. Negative 1. That is our M worksheet has that down also.
You have the.
Yeah, this 141 through 150 is the midpoint theorem. Yeah, that is coming. And the gravity, centroid. Oh.
Here you go. I'll just look over your shoulder. See, this is good.
Yeah, 153 is that. This is the y minus y, x minus x, and that's the point slope form. Point slope.
And slope.
Company, the school, they say point slope form.
All my high school assistants, this is all they're familiar with. You know, they don't know the other.
So that's a good section also.
Yeah,
if you
that's
want
right.
to do it, right?
This is, yeah, algebra, even some advanced class, they do algebra.
Even in geometry, they cover that, right? Do they
Yeah,
cover it, right?
that's it. This is what they do this in geometry. Only this way. Same about this area. Perpendicular.
Equation for the straight line.
This is on perpendicular. What's it?
Equations of circles.
What is
This whole section is good.
This is they show original the slope M1.
M2
Yeah,
same thing. Yeah.
So that's if they are using this, some students make mistake. They cannot find out slope correctly, right? So what they do, perpendicular. Oh. The perpendicular, what they say is, right? So I told the m prime equal negative 1. So, right? The school, they teaching, flip this number. Anyway, change the sign first. Change the sign first. Change the sign, going to positive 2. Then flip it, so 1/2. So new slope equal, right, 1/2. So this one times this one equal negative 1, yes. Right? Negative 2 times 1/2 equal negative 1. So that's they say change the sign first, then flip it. Then when you multiply, right? Two numbers, there two slope each other, that's not going to negative 1. Yeah. That is how they teach.
Negative 1.
Yeah, negative m, negative, yeah. This sometimes this one equal negative 1. Product is negative 1. Right? Original slope and the new slope product. Right? That product of the original slope and new slope.
It says actually right here. It says in order for two lines to intersect at right angles to be perpendicular,
yeah,
their
that's right.
slopes must be negative reciprocals of each other. Yeah.
Opposite. Yes, so that's why at school they say change the sign.
Change the sign.
Flip it.
That's it.
That's the new slope. Yeah. So teacher also teach, right? Try to all students understand easily. Yeah. Even they cannot do the calculate, it's okay. Flip the change the sign. Flip it. Yeah. Otherwise, there's some students plug in this number. They make mistake actually. Yeah. Sign wrong or equation, solving equation wrong, right? That's why
Change the sign.
Then passing through this point, right? Yeah, this point. So that's the new slope is this one. So they do y minus 3 equal to new, right? Slope here, x minus 2. That's the equation. Yeah, new equation.
For the line
Line perpendicular to this
that
graph. Yeah.
equation.
So y equal 1/2 x, right? This one minus 1, then move here, so plus 3. So let's say the 1/2 x plus 2. Yeah. They do this one in the geometry. This one was parallel, perpendicular. That's why the
So we do have certain,
but we don't have a perpendicular, right?
we don't have the perpendicular.
H.
This one
Parallel,
is
yes.
perpendicular, right?
This one, no, our H.
Oh, our
Our
edge
is
doesn't
just
have
parallel, parallel.
It's just parallel.
Parallel.
But that's okay. if they
That's good.
practice
Yeah,
that
yeah.
much.
Then this is they run this one.
Yeah,
They can
yeah.
run. Yeah. But we have this one M.
M. So we have H and then M.
So that's
and
the
then
geometry. Geometry can help 141 also here.
Yes.
M141 midpoint theorem.
Yeah, that's also good. Yeah. So it goes all the way perpendicular and then straight
So
lines. and then
141 through
circles.
160. Yeah, it's helpful for geometry.
Even going further, Ms. Fujiwara, it's equations of the straight lines and then equation of the circles.
No, this is
This one? No.
this one later on.
Later. Pre-calculus.
Yeah, no. This one geometry. Maybe chapter 9, 10 that time, right? So that's the
Later.
second semester. Only at the circle. Then the circle and how to say ellipse, hyperbola. I told you that's they say the conics. The algebra 2 they do the circle again, yeah. But the geometry they do this one, yeah.
Later on.
Circle later on. So that's why if they do this one earlier, it's helpful. But only that section. Proof we don't have a proof.
Right.
Right?
There's no
Side to side to side, side angle side, right? Angle side angle. No, we don't have that one. They do that the first semester.
Gosh, that was so long ago that I did.
The reasoning also. Reasoning, oh my gosh, that's why first chapter 1 is the one. They have the point, they learn the point, line, kind of review. Then, that's some section says, right, midpoint. That's why that is M141 through 150.
What about our XT? What is it? The triangles.
That is totally different, yeah.
That's totally different. That's sine.
Lobe sine, lobe cosine,
Yeah,
and the
that's
triangle.
cosine. We don't.
Heron's formula, yeah, all this side
All that
given.
is triangles. 30 pages.
Then they can find the area. All this, even not the right.
That's trigonometry. I think. Yeah.
How to say scaling triangle, but all sides are given, so they can find this area. Not the height or something, but they can find that. They do that. What's number? 30, 11, 20, 21 or 30. They do this one. Yeah.
1 through 30. It's all triangles is important.
Area. So doesn't do well. Oops. Yeah, maybe you have a paper. That's maybe easier. Paper and kitchen towel, hand towel. Yeah, kitchen towel. Then get the water. Yeah.
Paper towel.
Paper towel.
Paper towel and wet it.
Wet.
Wet?
Napkins.
No paper towel? Oh, okay. That's okay.
Well, we can put this water.
Yeah. Yeah.
Maybe. But they're too dry, so
Yeah.
cannot. Yeah.
Oh, then that's okay. It's gonna melt.
Maybe the table here, right?
That's
It's okay,
Just
right?
wet it a little. We have to
Table here.
or put a spray on it.
Then
Put a spray
water.
on it.
Water.
Yeah.
Add water.
Just wet it a little.
Yeah, restroom. I go to the restroom. Yeah.
Yeah, yeah. Take it.
Or the drinking water there.
Any water. Here.
And then you didn't change your stools, huh? You
Yeah, I
did?
brought it back. I got it right here.
You brought it back, the stools, right?
Yeah.
I'm going to bring it back too.
I brought it back because, it's
They all broke.
splendid.
No, mine break every class.
And they're so uncomfortable. Did you see
Oh,
that?
There's somebody drinking water, so it's
And
okay.
they keep
Left
doing
over?
this.
Yeah, let's
Yeah,
go.
let's go. Okay,
I
okay.
have at least 50 of them broken.
And they'll fall out and end up in the floor. I'm like, oh, gosh.
That is easier.
But I have these wooden ones, but they are very big.
Yeah,
The IKEA
some
ones.
dried one. Yeah.
Are these IKEA?
No, this is Petronas.
Oh.
That's why. See, this is the right size. I have the one from IKEA and they're too broad.
Which one?
The stool,
The stool.
black stool break, all of them. Yours is
Oh,
okay.
the round one? Oh, okay.
I have 50 of them broke.
$4.97. $4.
That's what you get, right?
Yeah.
2 months of class and then they're gone. They are so bad.
I use it all time.
You use it or no?
Yeah, I use.
The black stool?
Yeah.
No break?
Some of them per year.
Every class 2 break.
Oh,
Mine.
what you
I
did?
think it's the same kid who breaks my
Yeah, I think so. Yeah.
I'm
Yeah.
seriously now
They-
I'm thinking I need to put camera.
They did, right? 2 legs hold the, right?
Yeah.
Whole body, right? Then they shaking.
They shake it and the top comes out.
That's why I tell, stop doing. I tell.
I tell them, but I don't know which
I'm very
kid is
strict.
breaking.
Stop
Every
doing.
class, 2
Mm.
stools. Every class.
You break, you need to buy. Yeah, so.
I tell them, I say, I'm going to make you stand up if you shake one.
Then normally, like $100, we exchange to the gift card, like $15 value, right? I tell, if you break $100, so I can buy the free.
Really?
100, come on,
I don't know. I need to put camera in my who's breaking all my stools. I'm short on stools.
1 year, maybe 10 break, 10 broke, maybe.
Mine
It's
is
good, right?
15 1 year.
Mm.
Some kid is breaking it, right? I'm pretty sure.
10 or less than 10, actually.
They don't
So
sit
if
on the
the
same
tied up
spot.
the screw in the
Uh-huh.
the other side, it's working out
We
also.
tighten it too much, but I don't know. Either I tighten it too much.
Mm.
The top comes off. Every class, the top is broken.
Oh my gosh. You need to have a group. Special glue that. Top right?
Top is the screw, right? It cut off the screw. What to do?
Yeah, I have the IKEA that stored history, right? Okay. You know the oil price is going up. That time is they designed the current one. Top used to the right, top is right, round, no hole.
No.
Then even the right, the has a side,
Mm.
they have kind of right, 3/4 inch wrapping.
Hmm.
But now they have a hole, right?
They have a-
They, I know, because right, they use this material, then try to get the same strongness. Yeah. So that's why that hole helped them use this material. Yeah.
Right.
So I have
My
everything.
husband found a stool, $48, wooden stool, 148.
Ooh.
Then I said, should we need to buy?
No,
Do we need to
no,
buy
no.
the $4 or that's too expensive?
Yeah, no. If so, right, $48, right? You can buy the 1 dozen stool.
I know. But what do we do? They keep
Do it.
breaking.
That's better.
Inconvenient.
But
Very inconvenient.
That's better.
Every
Cheaper.
class, my assistants are carrying the broken stool in the bag. Vishalu, another one. Vishalu, another one.
Yeah, that's a tell. You need to buy. Yeah.
Something.
Yeah.
Something.
The commander, hey commander. Oh, they don't do it.
Too much.
Behavior.
It is.
Discipline. Okay, so this graph is very good. Very good. Means easier than the previous page.
0, 0, 1, 1,
Okay.
2.
Y equal x square root x. This is the basic one. Sample. That's example. They show the plugging the value that they did actually. Then -2. Oh my gosh. Then inside the square root shouldn't be negative. So that's why that chart said, right? Table said x and y. -2.
Inside square cannot be negative.
Yeah.
It's an
What?
imaginary number.
Imaginary number, right? Imaginary number is normally we cannot show the value. Then 0, yeah, finally 0.
Oh, the x is negative. Yeah,
Yeah,
What am I
1,
I'm thinking the opposite.
but this graph doesn't have a negative, okay?
Yeah.
Right, okay?
So
1,
the I.
2, root 2, 3, root 3, 4, 2, right?
Mm-hmm.
But most of the students cannot plot this value. X equal 0, 0, it's okay. 1, 1 equal, okay. 2, square root 2, oh, what's the value, right? They show here bottom, yeah, 1.414. So,
Oh, underneath.
this
Yeah.
1.7321414 actually.
Can we use it, make it easier on squaring it and doing it?
Cannot plot.
That's too big.
Cannot plot.
So what do we do? They need
Only
to
the
know?
whole number 0, 1, 2. Next one is 9,
9.
3.
Yeah.
That is one. Yeah. So that's a 1, right? 2, 3, 4. Yeah. 2. So 5 more, right? So 3. Then connect. That is only the way.
Yeah.
Yeah, that is only the way we're going to. And the 16 are too much, right? Go to 4.
Yeah.
So slowly increasing the graph, right? That is one.
So what if they don't know under root 2 1.41?
Doesn't
It's
need
okay.
it. That's it.
Doesn't
1,
need to, right?
right? 1,
1 and 4 enough.
4, 2, 9,
Nine.
3. Connect. That's it.
Yeah.
So that naturally increasing, right?
Yeah.
Some students go to that, ha ha ha, no, no, that happens, no. So of course, the plot more points easier, right? Connection, connected, right? Draw the graph, but this is not possible.
Not possible. Yeah.
In Japan, when we learn this one, right, we have some jingle, so that's the memorize this one easily. Scale root 2, scale root 6. Yeah, up to scale root 6, yeah, we remember. Root 2, root 3, root 5, root 6. Root 7, they show here. 2.64, yeah.
Yeah, I just say that side.
So let's say that when you plot roughly, I took the limits. How do you know that? Yeah, yeah. Okay. Years ago, I input here. Jingle is here. That is coming, yeah, it's helpful. Yeah. Years ago, I know it.
It's good to know the roots though.
Yeah.
It's going to fall. It's going to fall.
To be right. When I go to the California, yeah, Los Angeles, we do the kind of similar. So that's I know they use the big one. But right, yeah, I know what angle. I'm very good at this. So water is best one. Water.
Hi, Jean.
Okay. We just started.
2500 Yale Street. So where are you now?
Okay. So now
Yale and
they do right negative. Oh, I shouldn't do this
Okay.
maybe.
Okay, you're welcome. All right, bye. It's coming.
Is he lost?
Yeah. But I think he got it now.
So this is y equal root x, right? Now they say y equal negative root x. What the difference means, right? Whatever the x is positive, right? Before square root sign, negative is existing, right? So that all value going to negatives. So 0, 0, 1, negative 1.
Same with that.
4, 2, but negative 2. 9, go to negative 3. Yeah, that's why they're here. This is right. Yeah. Then go to next page. They do 2, right? 2x means, right, whatever this value, double. 1 comes 2. 2 comes 4, right? 3 comes here. 3 comes here. 6 here. Yeah. then connect here. Then now half. This is y equal 2 root x. Now they say y equal half. Any value this one going to have 1 half. 2 here 1. Right? Okay. 2 here 1. Okay. 3 here 3 over 2. Yeah, 3 over 2. So connect, increase area. Oh, goodness.
So we don't really need to worry about the under roots, right?
Yeah, no.
Yeah.
Oh, this is too big. Should be half of this, right?
Oh,
Half of here. Right? Always half of here. This area is okay. Not easy to do also. So here. Oh, see. Hi. Anyway, pretend half. That is a graph. Now they do next one, like 152. I give the basic graph here. Zero, y, x, x. So y equal root x, same graph, right? 1, 2 here, let's go this way. This is y equal root x. Now, what they did, that they show is now new type. Y equal root x plus 2. Then when you bring in the value, right, you can see if x equals 0, right? X equals 0, this is square root 2, right? 1.4 something, right? It's okay. But right, if so, what we can make this one equal 0? X plus 2 equals 0, which means x equals negative 2. So need to start negative 2 here. Negative 2 and 0, right? Then x equals negative 1, right? Negative 1 here, 1. 1 here. And the 0, oh my god, root 2, right? 3 still, right? 3, yeah, no, I said 1 root 3, 2, right? 2 plus 2, 4. So that's why go to, right? 2, right? So we can connect here. Start here, 1, 0, go this way here. They go this way. Which means this is the original graph. But right, plus 2 means right, what number make the inside the square root of 0 means right, x equals negative 2. So this graph, square root y, yeah, y equals square root x plus 2. This graph is shifted, that translated. This graph, right, y equals to x graph. Negative 2 unit along x-axis. That is one. So they said the original graph is right, and school they said parents graph. Original one they said parents graph. So parents graph shifted to 2 unit left side, or negative 2 unit along the x-axis. That is one. Actually, they have this translation. Go this way, up, right hand side, left hand side, up and down. The SAT also, SAT they have this. This kind of. This is negative 2. Now they do the right, the y equal root x plus 2. X minus 2. I'm sorry, minus 2. This is what number can make the inside square root of 0 means x equal to 2, right? Which means this graph goes this 2 unit, right? Positive direction. Shifted 2 unit, positive direction here. So right, x equal to 0. X equal, right? 3 is 1. then 4, we're gonna do 5, 6. 6 minus 2 is 4, right? So that's a 6 going to 2. Then we can draw the graph like that. So this graph is 2 unit, okay? Shifted along x-axis. That is all. Now next page, 52b, 152b. They have this plus 1, plus 1, which means this graph
Yeah, same thing plus 1.
up.
Yeah.
Like if number is outside the square root sign, right? Radical sign, that term is a y translation going up. If the inside the radical sign is x translation, outside the radical sign, this number shifted y direction. Plus 1 means up 1. Right? This one going up 1. So start here, then same graph. Right? Same graph is here. So 1 here, right? Like this. Go this way. Shifted 1 unit to the y axis. Y direction. Then they do this graph, right? Now minus 1. So this graph, right? This graph, right? Shifted, translated. Negative 1, so start here. 0, right? X equal to 2, equal, right? X equal to 2 means 0. Minus 1, so start here. Then 3, right? 1, minus 1. So which means 1, 0 here. Then 6, right? 6 means square root of 4. So 2 minus 1. So 2 minus 1 is 1. 6 means square root of 4, right? Means 2.
Minus,
2 minus 1.
2 minus
1. Yes. 1. Yeah. Then we connect this. So everything connected by translation. So original function shifted left or right and up and down. Yeah, that's the connection here. Now 153. Yeah, this is kind of the same type. Okay, the same type. We did already. This one, but negative sign is before the radical sign, right? So go not above x-axis or something like. Go this one. Flip.
That's the 151A.
Yeah, I use green, but not good, right? So this graph, right? This graph. If this is one, this graph is this one. This one graph here, right? Now,
show on the 151 on the top. Just it's gonna go up, right? The top one down. That's negative x, right?
Yeah, this is the
yeah. Now it's x minus 2.
I use this graph, right?
Yeah.
But now they do, y equal negative root x plus 2, right? So this graph going down here. Same graph
going down.
Going down, yeah.
Oh, okay.
This graph, right? Negative sign here, then go.
Oh, okay.
Yeah. Okay, with x-axis. This.
Yeah, this is minus 2.
This one, y equal root x minus 2, right?
Right. Now it's negative. So
Yeah.
go down.
So now we use this one, right? Y equal, if the y equal negative root x minus 2. If so, we start this graph, right? This graph going to flip here, going down here. This is a graph. Okay. Then, I didn't mention that domain and the range. Domain is x, right? Area, and range is y area, right? So you can see the graph, right? Oh, y is here. Negative here, always negative. If the positive here, always positive. Right? When they shifted, right, like this one, a little bit different, right? Y minimum number is -1. I'm sorry, I didn't mention that. Domain and range. When you draw the graph, easy to read.
The first number where it starts, right? That's so -2 and 2.
Yeah. So 153 also, right? Same this graph, right? This graph is shifted just down, one down. Then domain is 1. Domain is x is -2 or greater. But the y range is 1. -1 or less. Right? This one, now this graph. Right? +1, 1 up. This graph is 1 up. Right? Then go this way. X is 1 greater than 2. Right? Greater than 2, infinity. Y is 1, right? Start here, 1 up here, then less than that number. So 1 or less. Now 154 is a new type. 154. We start 154. This one is like this.
So now it's -x.
Yeah, negative. X is negative. Oh, you said, Ms Fujiwara said that, oh, now inside school it shouldn't be the negative. Oh, why this one negative? That's a reason now. Yeah. Before they say y equal root -x. Oh my gosh. Right? Entire equation has negative, right? But entire inside radical sign cannot be the negative, which means x value need to be always negative. This negative, x value is negative, going to the positive.
Oh, so
Yeah.
negative
So
9.
that's yeah. That the graph is 1. Because x is negative. How to make the inside of radical sign positive means x value need to be always negative. 0 or negative. So that's the, they make the chart, right? Start, right? 0, 0. 1, -1 goes to +1. Then, right, they make the chart of 0. Follow this one. 0. Of course, if x value is going to positive, this is negative, right? So that's like that. Positive doesn't work for the x value. 0, 0. -1, 1. -2, of course, square root, right? 2. -3, root 3. -4 is a positive 2. Positive 2. -5, right? Root 5. -6, now the -9.
3.
Go to 3. Yes. Then we can plot. 1. Next one. -4. Then 2. -1, 9, 3. Then we can connect this side. But here. So yeah, this is all. Next graph is y equal -x plus 2. Right? This one also, what number can make the radical sign, inside radical sign 0? Mean -x plus 2 equals 0. So x equal 2. Right? So x equal 2. Start here 2, right? Then go this way. So this graph, right, translated. Right? Anyway, 2 unit along x-axis. So start here, but the same graph. 1 here, right? 4 here, 2 up. From here, 9 here means 7, then 3, right? Here. Then we can draw the graph here. Not easy, but here. This is a 2.
Is this 154 number 2 that you're doing?
Yeah,
And then
yeah.
now she's doing that.
Yes,
What I
number 2.
confused.
Number 2. This graph, yeah, not the right position. Yeah.
So how do I make it positive, right? That's the criteria. We have to make it positive to get the value.
Yeah, yeah,
The
inside the
radical has
radical
to be
sign.
positive.
Inside the radical sign, yeah. Then the first one is x domain is always x is 0 or equal to 0 or less than 0. Y value is less than, right? Before, yeah. If, right, before the radical sign is positive, always positive here. Right? If negative here, go negative. This inside square root is radical sign is negative. So that's the x need to be negative. Then go this way, but the y value, entire y value is positive or equal to 0. Right? Then this one, x is 1. They translate it 2 unit, right? By 2 unit around x-axis. So x value is right, x equal to or less. Y is greater than or equal to 0.
But why is it translated to the right and not to the left? What am I missing? Because if it's under the radical sign,
This one? No.
2 is under the radical sign.
2. If the 2 here, right, plug 2 equals 0. Inside the radical sign equals 0.
Okay.
So x equal 2 and y equal 0. So we started here on this graph. Then go this way.
Sorry.
0. If you go to negative 6, then
Equals 2 and y equals
inside square root is positive 4. Right? Square root 4. Then 2. Then after that, right, next page is 154. By using, okay, they do the all of sudden here. Okay, different one. Anyway, number 3, y equal, okay, that is y equal negative x minus 2
Plus 2.
and plus 2. So we learned some basic one, right, and up to the 153. So all of a sudden they combine, yeah, translate x, yeah, x-axis and y-axis, this one. Then this is one we need to calculate, right? What is make that? What number make the inside radical sign 0 means x equal negative 2. So negative was positive. No. Start negative 2. This one make 0, right? Then still plus 2, right? Translate this graph to the y, right? Along the y-axis, so up to here, right? So that's why this is a little bit higher here. I need to erase this one, otherwise it's confused. But I want to use this one. Next question. So
That's okay. We'll create another one a little bit. It's okay. It's okay.
Okay.
Yeah, it's
So
the same
just-
thing, we just run.
Yeah, okay. This one I erase, right? So this one 2 here, up 2, right? So that's I start here. Then x equal negative 2 here. Then if this one going to the positive number, if x going to positive number, or inside the square root is always negative. So that's the x need to be negative, right? Largest number is negative 2, right? Then 0. So next one is 1. If we go here, right? Negative, okay. Negative 2, negative 0, right? If negative 3, x is negative 3, this negative 3, right? Negative, so positive 3. 3 minus 2 is 1. 1 plus 2, 3 here. Negative 3 and 3. Next one. Maybe negative 6, right? Negative 6, negative this, negative positive. 6 minus 2 is 4. So 2. 2 plus 2 is 4. Right? Here. Then this graph start here. 2. So, right, this graph, right, this graph is shifted to the x direction, negative 2 unit x direction, and the positive 2 unit y direction. Yeah. That's the graph, right? Base parents graph is this one. 2 unit, negative 2 unit y, x direction, positive 2 unit y direction. Now, they do next one. They try to use this one, right? I erase it. This graph is this graph. I erase it. This graph is. They put negative sign before radical sign. So y equal negative. This radical sign, right? So that's why this graph, right, is going down here.
Adding 2 to it.
Going down here. But one more extra number coming up here, negative 1. So that's the originally this graph is just change the sign, right? Here. Then 1 down. So start here. This graph shifted 1 down here, not because negative 1, y direction. So this yeah. Going to like that. This is 1. So this graph, if the original graph, this one, going to 2 unit along the x-axis.
Right.
This is the run, right? Yeah, this is the original one, right? This is this, okay? So 1 unit down, that is the graph. If the parents graph this one, how to change? Translate 2 unit along the x-axis and negative 1 unit y-axis. So if you understand everything, yeah, 155. This is one. You can do it. Okay? This one front and back. Both. So that's this is kind of the basic, but still easier than the previous section. This section, they don't ask what is the minimum, what is maximum. So that's just to follow the movement of translation of the graph. Easy, right? So that's 151 we do. The basic graph, parent graph is y, they compare. Okay. Draw the graph. Y equal negative root x. Negative root x means different. Once
if we do the parent graph, then it's easier.
Easy, yeah. Yeah.
That's the opposite.
Find the parents first. Then they can do that. So graph here. Y equal negative, number 1. Y equal negative root x. Y equal number 2. Negative is inside. So many negatives. Y equal negative x. So they draw the y equal root x, very basic one. Here, right? Like that. This is the basic one, this one. Then negative here is right outside. Negative side outside means going down. So this is one, number 1. Number 2, negative is right. X has a negative inside the radical sign, which means go this way here. Go this way. Number 2. Number 3, this graph has negative, so going down. Yeah. Okay. Then we can, this is number 3. Original one, this is the parent graph, right? Y equals number 0. Number 0 maybe. Okay, number 0 here. So then we can read, right? How to translate it. Okay? So complete the following by using the above graph. y equal square root radical x and y equal negative, number one, x are symmetric with respect to the x-axis. Yeah, this one, right? This
This
number
one
zero.
or this one?
This right? So x-axis symmetric with the x-axis. Yeah, respect to the x-axis.
X.
Now, number one question. Question number one. Y equal radical x, this one, right? Zero, number zero. Graph. And y equal negative x, number two here. Symmetric with respect to the
Y-axis.
y-axis. And y equal negative radical x is this graph.
And number three.
And y equal negative radical sign negative x are symmetric. This one going down here, the x-axis. Then number three, y equal negative root x. Number two, right? No, number one. Number one here.
Yeah, down.
Is this graph what? And y equal negative this one. Going to this number three. Asymmetric y-axis, right?
Y-axis.
Yeah, respect to the y-axis. So yeah, 56. Yeah, 55b. That's a translation. Yeah, but the same concept. You can follow? Yeah, still have 55b. Okay, 55b. Then yeah, 55. Yeah, then other 56. We just follow the solution book. Number three. Draw the graph y equal number one. Y equal negative minus 2. Number two, y equal negative, yeah, no, negative is inside. X plus 1 plus 2. Number three, y equal negative outside, negative x plus 1 minus 2. Then they said the parent graph is 0. Y equal root x minus 1 plus 2. So we start here. Down here. So this one, what that inside here 0. Radical sign 0, x equal 1. Then up 2, right? Plus 2 here. Then now we know. Plug in the number, not easy. So this one, we know the starting point. So any graph, right?
So the domain will be 1, right? Because 1 minus 1.
Yeah, 1 or greater.
So 1
1
and 1 or
right?
greater, right?
Go this way, right? So what we draw the graph is, right? You know this one. When the 0 is this is the starting point, right? 1 go to 1. So 1 go to 1. If this one 4, up to, right? So from here 4, then up to. If 9 here, 3, right? 9 go to here, 3. Then plot. That's okay. So Otherwise, the student also cannot draw the graph. This is just a little graph, so increasing too much.
Once they do it nicely, few of them, I think practice, not
So
too bad to think.
now they understand, right? Same as the y equals squared graph, x squared. Vertex is, they find vertex. 1, +1, -1, +1, -1, go 1 here, 1 up. 2 go this way, 4 up. 3 go this way, 9 up. So they can draw a graph easily instead of the plugging the numbers. Same concept here also. Now we find, right, y equals 0, that 0, that x equals 0, y equals 0. This is the point here. Right? This is x equals 1, y equals -2. Yeah, this, we did, sorry.
Zero.
Parent graph. 0. X equals 1, y equals 2. Starting point. So from here, right, 1 go this way, 1 up. Okay, be lazy. 4 this way, 2 up, right? From here, 9 go this way, 3 up. Then connect. Yeah. Otherwise, there are some students always calculate. It's good, okay, but
It's common sense.
then they say, right, this if not here, right? So, do I need to draw the graph? Yeah, they say by graphing. Oh, that's it. I teach this. Oh, easy. Yeah. Especially entire K, a lot of graphing. They said by graphing. Yeah, the rough graph. But if you go 1 go this way, 1 up. Lot of kind of quadratic equation is there. Yeah, function is there in the level K. Right? If they teach this way, they can say, oh yeah. Rough, but still, right? They can maintain the similar type of the graph as the original. So that's here. This is a parent graph 0. Okay, number 1. Now negative sign here, which means haha. So same graph here, like here. Same graph. So start 1, x equals 1, right? 0. Start 1, but -2. So 2 down here. Then go right. So this one also start here, starting point. So this one negative means going down. So 1 go this way, 1 down. 4 go this way, 2 down. 9 go this way, 3 down. So we can connect like that. This is number 1. And number 2, okay, what to do with this? Oh, we need to calculate. What, right? Number. Make the radical inside the radical sign 0, which means this should be 0, right? So x plus 1 equals 0, which means x equals -1. So we need to set -1. Then plus 2. That's the starting point. This is starting point. Then, if negative sign here, entire that value inside the parentheses need to be negative, which means we need to go this way, right? If the x equals positive here, oh my gosh, all entire value equal negative, right? Even 0 here, oh, -1. Oh, we don't know, right? Value y. So that's why the entire value need to be negative. So go this way. So now, from here, right? 1 go this way, 1 up. 4 this way, 2 up. 9 this way, 3 up. Right? Then connect. That is all. Oh, not good, but pretend. Okay. Allow me. Should be symmetric. This is one. Like increase too much. This decrease too much. But still not good. But yeah. Change your eyes. Okay. Go this way. Now this one was the same here, right? Then the negative sign before the radical sign, which means go down. Starting point, -1 and -2, right? What make inside radical sign 0 means x equal -1, so -1, then -2, starting point. Then go that enter the negative sign radical before the negative sign exists before the radical sign. So go 1 go this way, 1 down. 4 go this way, right? 4 go this way, 2 down. 9 go this way, 3 down. So connect. Something like this. This I knew. Go this way. This is number 3. Then based on this graph, we need to read how to translate parents' graph to whatever they say. Number 4, complete the following by using the above graph. Y equal square root x minus 1 plus 2, this one, parent graph, we say 0. And y equal negative square root x minus 1 minus 2. It's a graph number 1. 0 and number 1. This relationship is this is symmetric respect to x-axis. Now, number 2. 0 graph, graph 0. And y equal radical sign negative, this expressed number 2. Number 2 graph is symmetric, respect to y-axis. You see? Number 3, question number 3. This parent graph, no, not this one. Now, graph number 2. Graph number 2 and question, number 3, right? We are working at
number 2 and
number 2 graph and number 3. So this graph, number 2 and number 3. What kind of relationship means respect to symmetric respect to the y, x-axis. X-axis. This one, number 2, number 3. Now, number 4, question number 4. Y equal negative radical sign x minus 1 minus 2. Which means
Hello. Did the construction get you?
graph number 1, right? Number 1, graph number 1 and number 2. No,
She
number
went there.
number 3.
Where is K level, Anna?
K?
Can Jean get 151 to 160?
Yeah, solution book is under here.
Oh.
Sharu, solution book is here.
I have mine.
I saw, but
don't
I
even
it's
use
yeah.
I don't even write with my pencil.
Solution book is
So it
right here.
doesn't go. Look at my K book. It's
Nice,
all
right? Cover. Yeah.
all over.
Okay.
That's
So-
my solution manual.
That's good, then I can steal it.
Yeah, you steal it.
And I got all the information.
Okay.
Yes.
So this
Because I
graph
just
is
did
graph number 1. This is number 1 and number 3. Right?
155.
Question number 4 is graph number 1 and number 3. This relationship, which means number 1, number 3. So symmetric respect to, yeah. Okay. That is kind of basic school. Right? Then we can apply, yeah. As long as, right, if this is x, okay, y equal x or y equal negative x, if the 2 comes totally different, that is the next page, okay? So 156 still x. That's right, the basic graph is 1 go this way, 1 up, 4 go this way, 2 up, 3 go this way, 9, 9 go this way, 3 up. That is all same. But starting point, right? Only that. So that's the 156, so we can do this easily, right? Scale root, yeah, question number 2, we can go. y equals square root radical x plus 2 is translated of y equal radical x 2 unit and the y axis, right, along the y axis. So number 2, y equal radical x minus 3 is translated of y equal radical x 3 unit along the x-axis. Number 3, y equal radical x plus 2 minus 3 is translated of y equals radical x negative 2 unit along the x-axis and negative 3 unit along the y-axis. Next page, we will discuss same type of a question. Right? Just a follow. Now 157. Right? Now they have a 2. So increase a little bit quickly. Today, Jim, we have a pink day today. Pink day. Yeah, she prepared nice one, but light reflection.
Even worse.
Yeah. It's worse.
Oh,
I
you
thought
put
it would be
just
better.
now? You put it just
Then
now?
Yeah.
I asked her, why don't you write off under this line? No, you cannot do. Write is all or nothing.
I can just turn off certain ones.
So if
Maybe you turn on the light for that room. And
Yeah,
then
you won't
close
be
it.
able to see.
yeah, that's right. That's right.
Very
Right?
dark.
If the
You try that.
people can see the light and the video or something, they can see. But we
Who cannot see?
more important is here. Sorry.
Is the expo lights up? No.
Huh?
The expo board lights up? Or it lights up?
No.
No.
No, you did.
So we won't be able to see there either. Right?
Ah, you said only this board
No,
itself.
if the reflection is really bad, even
That's what-
worse.
Yeah, so
Yeah.
we won't be able to see even that. with the
Nice
close light.
reflection. Yeah. Reflected, very nice.
I think it's going to fall. It's going to fall.
Oh, this one? Oh, okay.
Sorry, Ms. Fujiwara.
It's okay.
She has to do all the work. Teach us, do the board, rub it, everything.
I'm enjoying, okay? Okay. So now the graph is a little bit like me. Okay. Yeah. Y equal, right? Root 2x, that's kind of the parent graph, original graph. Okay? They don't show the equation, but graph, right? They show the graph. Yeah. So number 1, y equal root 2x plus 2. Number 2, y equal square root 2x minus 2 plus 4. Plus 4. Then they show, nicely, they show this one, very good. 2x minus 1 plus 4. Then number 3, y equal square root 2x plus 3 minus 3 equal, they did nicely. Real worksheet is right. This one. Parentheses, right? 3 over 2 minus 3.
And 2.
They guide us very good. That's why the still easy.
2 and 2.
If they don't show this one, yeah, well, I got to lay down. I tell, yeah. Graph right here. 0yx. Original graph. The parent graph is y equal to this one, right? X equal 0, 0. If x equal 1, square root 2,
Yeah.
1.4 something, right? It's not easy.
Yeah.
X equal 2,
Then y.
then 2. Yeah, 2 here. Next one. Oh my gosh, not easy, right? 9 doesn't work, right? So that's like the 8.
16. 4.
8 goes, yeah.
8 going to 4.
Yeah. If the 3 means that if the 3 need to be 9, the fraction comes, right? Right?
4.
9. 2.
How
4,
many values should we do? 2 is enough?
maybe
or
3. 3. But this when you multiply, if square root inside square root is 9, we can plot 3, right? How to get the 2 times, right? 9 over 2. So 4.5, right? 4.5?
Oh, we can do that?
Yeah, 4.5, right?
Yeah.
Is going to 3.
That makes sense.
Yeah.
Oh, that's what they did. Yeah.
So then 8, right? Or 8 goes to 4, right? 8 goes to 4. So you can connect, right? Roughly. This is number 0. Parents graph, 0. Then this one, of course, this one, 2 unit up, right? Start here, right? 1, 2. 2 unit up. 1 here, so 2 here, maybe here. Then you can do the same graph here. So number 1. Number 2, what to do? If, right? Yeah, it's okay. 2. Parentheses, which means that what number make that this sign equal 0 means x equal 1. So this graph shifted 1 unit to here and 4 unit up here. Right? So here. This one going to go this way. Oh, hold on, easy. Kind of this one. This is number 2. Number 2. Number 3. X plus this and that. What number make the inside the radical sign 0 mean? Negative 3 over 2 means negative, right? 1.5 here. And negative 3. 1, 2, 3 here.
No.
Then draw the same graph, right? I can go maybe go this way, just roughly. This is number 3. Then number 1 question. Y equal radical 2x plus 2 is a translation of the y equal 2x, right? Yeah, of course. 0 to compare to 1.
2 units along.
2 units
up.
Yeah. 2 units along the y-axis. Then y equal 2x minus 2 plus 4 is translated y equal 2x. Look at this one. 1 unit go to the positive direction. Yeah, that is one tricky one.
4 units along.
If they don't show this one, right? Most of the students say this one translated this one, oh, x direction 2 unit, y direction 4 unit. Y unit is okay, but this one looks like x direction 2 unit. No. Always, if x has a coefficient there, you need to factor like this. Always. That's a key.
So if you factor it then,
Take out 2 out.
right?
This is the unit shifted, which means x direction only 1.
1.
Tricky.
Makes sense.
Not 2.
Yeah.
Take out 2 out. That is even the how to say, any graph, and especially that one coming M trigonometry, trig M
Trigonometry.
trig also. They come up here. Y equals sine, right? X plus pi or something, right? Pi over 2. Something coming. If the y equal sine 2x coming plus, right? Pi over 2. Right?
Still x plus.
This is okay, right? This graph is right. Sine x graph, right, is shifted negative pi over 2 direction. If this graph is, I'm sorry, right. Most of the students say the sine 2x graph, right, shifted the pi over 2. No. This one also, sine 2 is outside. X plus pi over 4. That's why this graph just shifted negative pi over 4. you need to take out the coefficient, always. Otherwise, the wrong number will be given. So that's why they change this one, so nice. But if they don't do, most of the students say, right, this graph shifted to, oh, -2. Looks like easy, but not. Take 2 out.
Shifted
That's a point, yeah.
And in the example you used, it's going to shift
Take 2 out.
pi over 4 direction, correct? Is that correct?
Pi, negative pi over 4, yeah.
Okay.
Take 2 out, not this number. 2 out. That is always, we need to do this, yeah.
Yeah.
Looks like a simple question, but they love, yeah. Even the rest, yeah, how to say, the trick area, right? Pre-AP students, they are doing that, so they are tricked. A lot of students tricked. They forgot to take the 2 out. And especially the 1/2, right? Sine, sine. 1/2 x plus pi over 2. They said, oh, same thing, negative pi over 2. No. Take out sine 1/2 out. X plus, right? Pi. I think pi.
Oh, so now it shifts negative pi.
Negative pi, yeah. That is what they have to change it like that. That's the trick. That's here.
Makes sense.
Yeah, I think so. Okay. So that's a distance, right? This graph is shifted x equal to -3 over 2. Y direction is just same as this, but x is on. Yeah, very tricky.
It's those details that matter so much. It's those details that
Yeah.
matter so much.
It's that, because,
Yeah. But she knows. I
Yeah.
don't.
But number 2 question, right? Number 2, right? They don't use the, right? This one. They change. That's why right? They use this one, right? So the psychologically, oh yeah, this one, yeah, shifted 2, easily. But this is one, yeah.
So the x always needs to have a coefficient of 1 in order for us to progress.
Yeah. 1 million.
Always, I think, right? Before also we, yeah.
So inside parentheses, right? Need to
Under
be
the radical, it has to be, the x has to have a 1 coefficient.
So next page is, oh my God, 4x, yeah. The same concept, yeah. But now, right, before the radical sign, they put negative sign, right? That's why the graph is everything below, right, x-axis, below means under, right, x negative. If the shifted plus, of course, some portion going up, but the graph going to this way, this way, this way. Right? So they read this one. Then note. This is a note. Yeah. An irrational function of the form y equal radical k parentheses x minus p close the parentheses plus q is a translation of y equal kx. P unit along the x-axis and q unit along the y-axis. Similarly. Yes, axis. Similarly, next one, an irrational function of the form y equal to negative, radical sign k, parentheses k minus, yeah, x minus p, plus q is translation of y equal negative, radical sign, radical kx, p unit along the x-axis, and q unit along the y-axis. Yeah. So that's k, whatever the coefficient outside. So Vicky said, inside parentheses x coefficient is 1. Yes. We need to change that. Yeah.
I mean, why
But they didn't
isn't,
explain.
why isn't that in the example, x must be a coefficient of.
Yeah, it's not there. What you explained is not explained here. But they did it. But they solved it like that.
But they don't explain,
They don't
right?
explain. That's what she's saying,
That's
right?
why many students, mechanically they do. So that's why the question says, right, here, oh, this one going to 2, right, 2 unit. Looks like easily,
Right.
but graph-wise, yeah, always.
Even
yeah,
in this
we
note, they could have explained, right?
That's what I mean. Why is there not an example that says that?
Don't ask.
But we're not supposed to.
Yeah, even like that, the
How
started,
it's
right,
gonna work.
started, hi, what's the,
Yeah,
quadratic
the question
function.
is how much we need to teach.
Yeah, quadratic function, that is, we started that.
But you know, Mrs. Fujiwara, you said something about 18 months ago that has really helped me. And in making decisions, how much do I teach? What do I assign? You know, those kinds of things. You said something so succinct. You said, if I don't do this, I lose the student. If I lose the student, I can't help the student. And that has really helped me
Oh, really?
in decision making.
Oh, okay.
Do I want to keep you? Do I want to lose you? You know?
Yeah, yeah.
It's so simple.
Simple. Yeah. Then, right, L 181, 191,
Uh-huh.
even if students don't do this section, they can survive in this country with good grade. So if keep giving that area, it's hard, very hard, complicated, time consuming.
Right.
They quit. Oh my gosh, they don't know the trigonometry
can't help.
trick.
Right.
So 20 sheets, close your eyes, skip it. They move to M. 1, 2, trick also. They do this and pretty out. Very important. Yeah. They can learn more instead of the 20 sheets. Yeah. It's hard actually, complicated, time consuming.
What I feel.
But then it has just helped me so much. And do I keep repeating on this where they're just doing this? Or do I let them go on?
Let them go. Yeah. Right? Not all students going to the mathematics area
No.
and the physics area. But the basic knowledge, right? Sine, cosine, tan, they need to know to do the right, some kind of the right, some area work. But right, 181 L, 191, 181 connected some physics. Moment, how to say the motion work or something. It's okay. But the physics has a more kind of formula. That's kind of, it's hard.
Right.
Yeah. So, but general students, they know that they go to the economic area, economy, something, they don't need it. They don't need that. Yeah.
Law school.
Law school students, they know the sine, cosine, tan, it's wonderful. Wow.
Even medical school.
Yeah. Yeah, they don't need the kind of motion practice. They don't need that. That's why if they make the machine, they do in the special area. They run that. That's the kind of the 181 to 200. Yeah. But that, or they finish everything, then after all, L 181 to 200 maybe works.
Then you
But,
can go
yeah,
back.
because they just run, right? Oh my God, say 1 up to 180, then apply many things. So that's why they may not master well. Then it's hard. The N, right, and the calculus area, and all calculus area after that, still time consuming actually. But they can do it. Yeah, later on, yeah. Then 158, this is kind of review area. We got this one. Then 159 looks like the kind of minimum, maximum coming. So yeah, not so hard. Okay, so describe how the following graph has been translated from the graph y equals negative x. This is summarizing. Number 1, right? Original one is y equal negative x. Number 1, y equal negative x plus 1 minus 2. Right? This one also, you can do this one. What number equal this one equal 0? That's a value, right? Shifted. But they guide you because previous page we did this one. Negative x minus 1. Then you can see clearly. Right? This one graph going to 1 unit. If the coefficient of x equal 1 or negative 1, still you can find what number make the radical sign inside the radical sign equal 0. That is a kind of the translated unit. Translation unit. So based on that, you can see 1 unit x-axis because this is positive, not this sign. This is positive, right? So 1 unit x, right, axis, then negative 2 unit y-axis. You can do it. So number 2, negative x minus 3. We can change this plus 3, right? Let's say this one going to negative 3. Number 3, y equal, not negative, plus 2, plus 3. Negative x minus 2 plus 3. So 2 unit x-axis, 3 unit y-axis. Now all of a sudden they put the 5x. It's good.
The find out.
You can do number 2. They say y equal radical 5x. Number 1?
It makes so much sense when you say coefficient has to be 1.
Yeah.
Well, and I was just thinking that, and even in number 3,
Mm-hmm.
the first example, the coefficient is negative 1. You can't have that, you know? I mean, it's just
But still that this one, what number make radical sign inside the radical sign equal 0?
Right.
That is works.
but it's the same thing, but still,
Still,
that
yeah.
makes this extra step understandable to me.
Yeah, yes,
But
yes.
until this, I would have
Yes.
understood why you did that.
Then 5x minus 10 equal plus 5. Okay. So take 5 out. X minus 2, right? Plus outside 2. 5. So 2 unit x-axis, 5 unit along the y-axis. Then all of a sudden, number 2, they give the kind of easy one. Y equal root x minus 10. No, not changing side required. Just read. This graph, shifted, translated, 10, negative 10, yeah. 10 unit down, or negative 10 unit y-axis.
Well, this makes so much more sense.
Yeah.
So much more sense.
So y equal 5 x plus 2. So this is the one, right? Just, yeah, so 5x plus divided by 5, right? Minus 3. So that's here, 2 over 5 negative, right? Unit x-axis and negative 3 unit y-axis. Same type of question the other side, yeah. Then now 159, this is kind of they give the domain. Then we need to find what is maximum, what is minimum. Just a bit dry, so I want to use that one.
It's all pink.
Yeah, all pink. Yeah. So, wow, this also. Oh,
okay.
we
Don't
can,
worry
yeah, we
about
can
it.
wipe, yeah, we can wipe. We can wipe. Water is wonderful, right? Very powerful. Okay, now 159. So now that we can image the graph easily, K1959. Graph says, right? Example, fx equal x plus 2 plus 1, negative 1.
Negative.
Then domain said x greater than equal to negative 1 and greater than equal to 4. So we need to draw the graph first, right? Draw the graph here. Draw y, x. Right? X equal negative 2 here, start here. Then negative 1. So this is a right, starting point. So for this say, right? 1 go this way, 1 up. 4 go this way, 2 up. 2, so 2 up. 9 go this way, 2, 9 here, yes, 1 up here. So start here, graph like that. But, right, this is negative 2. We cannot draw the whole graph here. Only this domain we can draw the graph. So this is negative 2, right? So this is not the one. This dotted line here. Start here, right? Graph is here, but the real line graph is only here. Here, 2, 4, 4, 6, oh, the minus 1 here, here, something here, up to here. This right? This is not dashed line here. So 4, graph wise, right? Here to here, that's the real line. Solid line. Others are dashed line, right? Like this. Then find the value, right? Minimum, maximum. Oh, very good visually. This is minimum, this is maximum. So if when the x equals negative 1, minimum. So we need to calculate here, right? So from the graph, right? From the graph, if negative 1 is a minimum. So from negative 1, so negative 1 plus 2 minus 1. So this is 1 minus 0. F4 is a maximum, right? So 4 plus 2 minus 1. So root 6 minus 1. Yeah, we cannot simplify this anymore. Right? So that is the value. So this is minimum. This is maximum. So number 1 we do. That is the same style. So
Yeah, it's exactly the same.
Number 1 is right, negative here. That's right, good. Graph is negative. So fx equal to negative square root x plus 3 plus 1. Then domain is x equal to negative 1 and 5. So graph is 1, right? Okay. This too big here, maybe here. So then this graph is 0yx here. X need to start right, negative 3. Then plus 1 here. Then negative, so graph go to this way. 1 go this way, 1 down. Right? Then 4 go, this means 1 here. Then 2 down. 1 here, 2 here. From here, 9 go this is 6 here. Is 3 down here. So something like this. This graph is this is a graph here. This is a negative 3 and 1. Yeah, right? But we can draw this graph only
The basic.
x equal 1 here, 1, and 5 here. So this is a dashed line, right? Yeah. Okay. Oh, it's ugly. Okay. This is a solid line here. Then we need to find out what is maximum, what is minimum. Yeah. Visibly you can see this is a maximum, right? X equal 1. So fx f1 negative 1 plus 3 plus 1. So which means it's a negative 2 plus 1 equal negative 1 is maximum. Max. Minimum is F5, right? Negative 5 plus 3, sorry. Oh, this is zero here.
8 plus 1.
Plus 1. So negative square root 8, 2 root 2 plus 1. That's a minimum. Okay. So same as the 59. Exact same. So anyway, we cannot draw the graph entire, right? So only the partial based on the domain. So now the graph matching. Oh, that's fun. So you can do that. This is the entire review. Graph number 1, right? 160. We do, right? Look at the solution book. So I don't write. Y equal radical x minus 1 minus 2. So we can find the starting point, right? X equal 1 and negative 2. Which graph looks like, right?
Yes.
Which graph looks like? Yeah, negative 1, yeah, plus 1 and negative 2. Number 2, the graph go down, right? Basically down because before the radical sign, negative sign is there. 1 and 2 is a starting point. Graph is 1, positive 1 and positive 2 is starting point, but going down. Which means exact C, right? Yeah. Then number 3, y equal radical 2x plus 2. Take 2 out.
Negative 1.
Then x plus 1, right? So negative 1 and 1. Negative 1 and 1. Then go to just regular. Looks like F. Then number 4, radical is before radical sign negative. So go this way. Graph is go this way, right? Then and x, negative x plus 1 plus 2. So take negative sign out. Yeah, x minus 1 means right 1 and 2. 1 and 2. Then negative going to this way, right? So which means
B.
graph B. Yeah.
B is long. F. C.
This way and this way, right? So there, yeah. Number 5, 2. Take 2 out inside the radical sign. So x minus 1, right? So 1 and negative 1. Starting point is 1 and next, right? Negative 1. Graph going to down. Yeah. Yeah. Graph going to down. Number 6. Take negative sign out. X plus 1. Which means negative 1 and negative 2. Negative 1, negative 2. Then x is negative, so that's going to this way, right? This way. That's positive. So if you can image the graph, right? Then easier to find out.
So if it's negative x, negative 1, we take the negative out. So it's x plus 1, so it's negative 1. Right?
Because it's x plus 1,
Yeah.
right?
Yeah.
X, negative. Sign is opposite. Yeah. Mainly the test or something, they do that one. Because psychological trick, right? If the plus coming, need to x value need to be opposite, right? That's why teacher love that one. Especially last one, yeah.
Last one.
Last one. Negative x, negative 1. Yeah. They say negative 1. No. Yeah. They say take next x out, right?
Yeah.
Negative 1 is okay, but x, right? But this one they say, right? Oh, looks like the negative 1 means, oh, this is positive. They are thinking, oh, no. So this is what they take this, they put this, the trick. Even SAT also. If this minus here, most of the students get answer right. Here, this most of the students answer right. But positive here, many students make mistake here. They don't change the sign.
Why?
Huh?
They did the opposite, right?
Yeah, opposite. But they know it, but they're psychologically, right? Maybe if when they get test is right, there's a totally different psychological atmosphere, right? So that's why they knew it, but they are psychologically tricked. Yeah, psychologically tricked. Yeah, that's why the test is, more students are tricked. They put that question on the test. Okay, then 160, we did this one just now. Let's review. So we don't do it. Then just a note. Yeah, no, yeah. Vicky, could you read?
The note on 160B,
60B, note.
given an irrational function of the general form y equals the square root of k times x minus p plus q, the domain and range of the function are as follows. When k is greater than 0, domain x is greater than or equal to p. Range y is greater than or equal to q. Trying to think of this as I read it. Okay. When k is less than 0, domain x is less than or equal to p. Range y is greater than or equal to q.
Y is same, but x is the one, right? If the inside the radical sign x is negative, right? Entire value inside the radical sign need to be positive. That's why take the negative sign out. Yeah. That part inside parentheses need to be negative. So that's why they go to this way, left-hand side. X value. Yeah. If real number, they use a real number is kind of more kind of right. That has a detail they can understand easily. But if they use the kind of right, that has an alphabet right, unknown number, they cannot image easily.
You have to have two negatives.
Then
when k is
positive, yeah, k is negative, yeah. Then next one, yeah.
Oh, you want me to read that?
Yeah.
Okay, an irrational.
Here, he's the one.
Your turn.
Yeah.
An irrational function.
An irrational function.
In the general form y equals the square root of k x times the quantity x minus p plus q is a translation of the graph of y equals the square root of kx, p units along the x-axis and q units along the y-axis.
Yeah.
That makes sense.
After the k,
Yeah.
right?
Yeah, that does. Right? Got it.
Then
So I need
that's
it.
Charu, yeah. Thank you.
The rough graphs of some common irrational functions are shown below. So ya is y is equal to under root x, which is on the
Parent graph, right? Parent graph. Yeah.
exactly.
Yeah.
And y is equal to negative under root x, which is right below, just going to negative along the y-axis. We did that.
Yeah, that's why this is summarizing.
Yeah,
right?
it's just summarized.
Yeah, they summarize. Yeah. So that's why the parent
Good.
graph.
It was still better
This is y equal x.
than the
Y
earlier
equal x.
worksheets. This was much better.
This one go to here. Y equal negative root x. Right? So go to this way.
It's inside the other row.
Y equal negative x. This one both, right? Y equal negative x. Right? This one. This is the old style, right? Of the graph. Then plus coefficient something here. Make it more complicated. That's it. Here, once you understand, yeah.
Perfect.
Easy, yeah. You grasp everything. Then the minimum, the domain is given minimum right? Maximum easy, not complicated, yeah. Because graph is connected everything here, yeah. Continuous, so. Okay, so distance sheet is done.
Yes.
Yeah.
30.
Next
Fujiwara?
one, yep.
Okay. No, go ahead, you finish.
No. Next one, let 161 through 170, yeah.
161 to
Through
170.
170, yeah. If we know this one, then easier. Graphic, draw the graph image here. We can do. Then other graph, right? And the intersection is coming. From here to here, one question on the test. Solution. Yeah, that's the K achievement.
141 through 150?
160. 160.
How about 141 through 150? No, 151 through 150, what we did today.
This one, I think the basic, I don't care. It is not there. Because, right?
It's easy.
161 through 170 is more complicated. Then they have a question. Then the graph here. 141 through 160, 150, yes.
My question was, Ms. Fujiwara, in the training also somebody mentioned that you had your notes about, how you explained us. I think when I started with I. The G and H and I, maybe J I started probably. Last, you have your notes, how you taught G, H, and I?
I have.
You have them? Notes or you have the presentation, Ms. Fujiwara?
Just the notes.
Can I have them? Just for the for the assistance or how to help. Although I feel comfortable, but do we have that on the?
No, the video is only starting K, part of K and up.
Oh.
Before I was trying different variants.
Yeah.
I'll go back and look.
And see, I think